Find the zeros of the polynomial p of x equals 2x cubed minus 4x squared plus x plus 1. Remember, the rational zeros, we'll start with those first, are of the form factors of the constant term divided by factors of the leading coefficient. So these will be things of the form 1, those are the only factors of the last term, divided by either 1 or 2, those are the factors of the front coefficient, and then any possible sign combinations thereof. So we've got 1 or negative 1, or 1/2 or negative 1/2. We're going to try each one of these using synthetic division and see which ones work. So we'll start with x equals 1. And then we'll divide this into, we'll put the coefficients of our polynomial. So 2x cubed minus 4x squared plus 1x plus 1. We carry the leading coefficient down, so we've got a 2 here. And then we multiply. 1 times 2 is 2. We add these together, we've got negative 2. Then we multiply these. 1 times negative 2 is negative 2. Add them together, we've got negative 1. Multiply again, so 1 times negative 1 is negative 1. We add these together, we get 0. That's good. The fact that we have a remainder of 0 says that x equals 1 when and evenly. And the other numbers that are here are the coefficients of the depressed polynomial. So we've got 2x squared minus 2x minus 1. Now we also want to know where this is 0. So we could either factor this or maybe use the quadratic formula. No factoring is jumping out at me, so I'm just going to plug this into the formula. We've got x equals negative b. So a is 2, b is negative 2, c is negative 1. So negative b is 2 plus or minus the square root of b squared minus 4 times a times c all over 2a. Go through and simplify what's in the radical. So we've got x equals 2 plus or minus the square root of 4. Now we've got negative 4 times 2 is negative 8 times negative 1 is positive 8. And this is still all being divided by 4. If we simplify the radical further, we've got 2 plus or minus the square root of 12 over 4. And then 12 we can break apart, and we can write this as 2 plus or minus 2 radical 3 over 4. Now everything here has a 2 in common, so we can factor out the 2 and reduce, which gives us 1 plus or minus 1 radical 3 over 2. So our zeros are x equals 1, x equals 1 plus radical 3 over 2, and x equals 1 minus radical 3 over 2.